Hello. I see a couple people don't have the ability to do audio video. This is I figured we do a study group. I like to do some advanced stuff sometimes. And I do some beginner stuff, some intermediate. I'll go as advanced as you guys want to go. Feel free to take yourselves off mute if you can, or talk in the chat if you want to. If you are unable to take yourself off mute, I don't know where I'm. This is my third time using this new platform for our study groups. So put it in the chat that you tried, but you can't do it. But I like to see if you guys can talk or chat about reliability. I got some stuff. I'm going to use some of our curriculum from our classes. I got something prepared, but I'm happy to take the way I do study groups. I'm happy to take it in any direction you guys want to go. Since you took the time to come here and see us, I see a couple of old friends and. I don't know. Maybe I know all of you, Casper. I'm not sure. Do I know you, Casper? If not, put in the chat. If I do, I don't say a last name. I think I know Rum. If you're the guy, if you're the one I met in our class earlier this year, I know you. So it's good to have friendly faces back. Let's talk about what reliability is. I'm going to use my some of my architecture stuff, but this is going to be an advanced dev as well as architecture. We're not just going to stay only in architecture. I want to give you a reference. It's a study group, right? So you can go buy this book, Site Reliability Engineering. It says Google on it, but it's not really about Google. I want to take some of the stuff that's really useful for our Mule integrations from SRE, is some language around what we mean by reliability. And I think if you imagine, like, if you want to make reliable software, you have to have a way to be explicit, to be specific and measurable about what is going to be reliable, right? You want to make a good promise, right? So there's these three different values, or three different concepts we use related to this notion of service levels. I want to build a software service, whether it's an integration service or a user interface or a database or whatever. In MuleSoft, we're probably building integration services. There might be APIs, there might be ETL processes, but we want to have some level of service so that it can be relied on by somebody, right? So a service level indicator is something that we are measuring, something we care about. That's it. It's something we care about, like a availability metric or a performance metric. It's something we can measure that matters about the system performance. Service level indicator, right? Then you can set an objective for that. Like, I want the system to be up 99.99% of the time. That would be a service level objective, right? So you can have an objective for that, and now we have something we can engineer for, right? So service level indicator is something we can measure. Service level objective is something we can design for. And a service level agreement might be a arrangement, might have a consequence to it. So a service level objective that would have, if the objective is violated for a certain amount of time, maybe there would be a scaling. A service level agreement can be legal, but it can also be technical, right? So it might be that if a service is down for more than an hour, we're going to stand up the same service in another region of the world or something like that. So I found that pretty useful from the SRE book. And for Mule applications, I kind of put my own little diagram together of three SLIs, service level indicators, that interact with each other, and that we can design for reliability. So latency, throughput, and availability. These are all specifically measurable quantities, and we can design our application as strongly as we want to meet these requirements. And of course, that's why I put risk and money in the middle of the triangle, because the higher your service level objective is, the more it's going to cost you something, right? So nothing's free, and there's no such thing as perfect, right? We can increase reliability. It's a matter of degree. It's not perfect. So I guess that's where I would start. There one element of making integration applications reliable is having them recover. So a big part of being reliable is recovering when things do happen. I found I'm not going to do the 8 fallacies of distributed computing are relevant for Mule applications, because we're building integrations in distributed systems, and none of these things are true. And this is what causes our systems to be unreliable. I found a really interesting source for studying reliability called resilience patterns from Uwe Friedrichsen, and that's his Twitter at the bottom right. And a lot of what the patterns we use in Mule applications for designing reliable systems can be drawn from, this is kind of a superset of those. Like we have idempotency in here, we have asynchronous event-driven applications in here, error handling and circuit breakers and timeouts. We use these design patterns as part of our API designs and our integration designs to cause them to be more reliable. And each one of these, you add a design pattern, it's going to make your application more complex. So I'll probably dig into doing those. So I want to start now with maybe a more intuitive approach to reliability, if you like. Maybe I can do it this way. Maybe I'll use a diagram. We're going to do live curriculum design together today, because how much of our integration is really done with just APIs. Right? Most of it, right? A lot of our integration is based on simply API design, right? And we're going to start with this a view of reliability in terms of providing a service. Do I have one here? Here we go. We'll do a new one here. We're going to provide a service. Here's our little service we're providing, right? And a service in terms of the most popular ones. I won't stick to just these, right? Let's take the common case. The most useful use case in Mule service might be a REST API that we're building, right? So we want to make a reliable REST API. In order to have some notion of reliable, we have to have a client, right? The client is what would rely on it, right? And the client is operated and designed by some consumer, right? The consumer is using our service, right? And they write a client software, they use the service. So let's just imagine a single use of our service. Now, our service itself, even if our service is a simple little thing that adds two numbers together, it may not work, right? So I have a request that comes from the client over the network, right? And that's where it starts. Now we know we want to do 2 + 2, right? So that's the client sending a request, and it wants to be able to rely on the API to work, right? What could go wrong, right? So some things could go wrong, right? Our service, even with no dependencies, services can break because they do have dependencies on network. They do have dependencies on power, right? And there's two steps, right? There's an API, an HTTP API has a request and a response, right? And both of those messages have to be transmitted in order for the service to provide, satisfactory level of service, right? Let me make that bigger. There we go. Right. So that would be what the client is hoping for, right? And if the client were not to rely on our service, if our service was to prove itself to be unreliable, where could it break? Right. So we would imagine places it could break and what we can do about that. Right. So it maybe the application could crash, right? That would make it unreliable because and when the application crashes, maybe the request could fail, or maybe the response might fail, right? There's two steps there where the client might notice that the application is unreliable. This would be an availability concern, right? And we can do things to improve the reliability just at this layer, right? And we do that with MuleSoft all the time, right? You want to put in the chat, this is a study group, right? Oh, thank you for the comment, Mark. I am sharing a different screen. Let me fix that. Stop. Share. New platform. No excuses, right? No excuses. So this is what I was drawing. There we go. Thanks for that. Live curriculum design. Yeah. So I wanted to really come down to the most fundamental microcosm of reliability design. Like, what can we do now just for this simple service? How can I make it more reliable? Any ideas? Remember, it's all reliability is a trust thing, right? It's from the perspective of the consumer who operates the client, right? Right. So this person is going to have a experience of using our design, right? So our service. This consumer's going to have a problem or not, right? So how can we make the consumer experience a better reliability in the case of an application crash?
You could have another instance of the application running in real time along with it, mirroring it basically.
Yeah, I could have like 2 copies of it running at the same time. Now the trouble is at each of these different kinds of failure would be different for that one, right? So in order for the request failure, what would happen with a request failure? I would have like some the kind of request failure problem you'd have is a DNS lookup failure or a connection timeout. You could have a connection timeout, right? You could have connection refused, right? So on the network path from the client to the service, there are a few different the kinds of troubles we're going to have before the service receives the request are some of them are on the client side of the connection, like if the client has their own internet go down, right? So that's not gonna we can make more copies all we want unless it's running in their house, right? It's not gonna help them, right? But so we're gonna do as much as we can, right? So we can't do anything at the level of like the client's own premises, but there's a certain point where we find ourselves in a case where we can do something about it, right? So if I wanted to try to make this request be able to reach either one of these 2 services, how could I do that? I see a chat. It says load balancer. So that's another service, right? I can add a service in front of my service. And I know everybody's seeing it, right? But this is redundant. It is a form of redundancy, right? I'm adding a service whose job is to keep track of what backend services I have and forward the request to the proper backend service, right? That's a reliability step like that. There we go. That works. And then, oh, let me put a little arrow on there, right? So I could add a load balancer. And then, of course, the response is going to have to go back to the load balancer because the client has now connected to a proxy, to another device. Now, what do we do about, we have the same kind of problem, right? What do we do about the load balancer being broken? So this is, I'm using an application load balancer in this one, app load balancer, right? There's a couple kinds of load balancers. App load balancer. Yeah, RAM. So, okay, I love that, RAM. One thing you could do is you could put client-side logic in the client, right, to do a reconnection, right? So the client can have 2 different DNS names that they're using, right? The client could have an east api.east.company.com, api.west. So one thing we can do is we can put a little bit of logic on the client side that says client side failover, right? So that's another thing we can do to make this API call more reliable, right? We can also run a cluster of load balancers, and that cluster can use low-level traffic to use IP sharing or something like that. So at a site, right? So we can have site. Let me do all of them here. We're going to have a second site load balancer, some kind of second site out there, DR, right? Right. And second site services. So we can make things more reliable by having copies of them and letting the client be able to redirect to another load balancer or to a second site, right? And at which point of the network chain for the request we have the redundancy implemented. All right. Anybody have any idea how to do this stuff? Let's do the I'm not going to do RAMs yet, right? Let's do the load balancer part. How do I do the load balancer part in a MuleSoft deployment? Let's assume Cloud Hub. We can always do RTF or on-prem second. So Cloud Hub has got a built-in load balancer, right? There's a one that comes out of the box. So it already provides one that does basic load balancing for you. And that's valuable. Why? Because Cloud Hub Load Balancer, the shared one, is a cluster. So what I have here, if I put like a site around this, like this, here's a site. This is like a Cloud Hub region, right? And all of that stuff is in one region, right, of Cloud Hub. And that's still, it's helpful for Cloud Hub to have a separate load balancer from our application, because there's a lot of reasons that our applications might break that would not break the load balancer. You could run out of RAM, right? You could run out of disk. You could get really slow. The application has much more that can go wrong with it than the load balancer does, right? So this is a risk reducer, right? The kinds of things that are going to break the load balancer are fewer than the kinds of things that are going to break the backend service, right? So Cloud Hub already does that with a shared load balancer. You can get a dedicated load balancer. And then for Cloud Hub 2.0, there's a network load balancer that's part of the runtime fabric services. So both versions of Cloud Hub do this on the request side, right? Now, for reliability, that's the first part. We've provided an availability. We have some patterns for availability, both on the client side and the server side, just to get the request to go to the service. Now, I still need the answer to come back from the service. Now, in this case, there's no reliability risk because this is a safe idempotent operation, right? Doing 2 + 2 = 4. Let me kind of get rid of all that stuff here. Let's simplify the picture again, because I want to just do the next level of the next thing that could go wrong. You have to be kind of a pessimist with reliability. So here I want to do my simple service again. Let's imagine now, once the request makes it to the service, there's no way the client's going to be wrong. It's either going to get an error back, or it's going to get or it's going to get the answer back, right? It'll get some kind of error, or it'll get the answer, right? And if it gets an error back, the client has patterns it can use, like a retry or a fallback API. So the client has reliability patterns on the client side, like Ram was bringing up, where it can try again or find some other way to get the answer, right? And that's because this is a safe idempotent operation. Now, there begins to be more trouble when we have a dependency, right? When we have a dependency, now not everything is in our service's control, right? Maybe it's a database or a cloud service or something, or a disk folder or something that's not under the control of our service, right? So 2 + 2 is no longer the right kind of operation to look at for this. And now we need something that needs the help of the backend service, and adding numbers probably wouldn't be that. So what about a unsafe operations, right? What about something that's like a write or an insert? So let's call this like let's call this like how about change address, right? So I'm going to provide a new address, and we're going to get back what, right? 200 okay. Yeah. Well, I like what you're saying, Ram. Right? Well, I don't want to roll back if I put a 200 okay, right? So for the HTTP REST APIs, what's very reliable about it is that it was designed to be synchronous calls. Synchronous calls do not respond successfully until the work has been completed, right? So there's no way that the client has a partial success of the operation, right? 200 means done, right? So in order to do that, when the service goes to the dependency to make the change, the service is going to wait. It's going to block until it gets a response back that says success, right? Right. And as long as it gets success, then it will answer success to the client, right? We have to wait around. That's a latency cost. And as a result, we get the client knowing for sure that the operation succeeded, but before the answer was sent, right? Before the 200 OK was completed, right? And in order for our service to do that, our service just simply has to block and wait for things to complete properly, and we're good, right? Right. So we don't actually need rollback yet. We don't need rollback until there's a reason to undo things. We're going to, of course, look at sometimes there are reasons to undo things. MuleSoft has a whole pattern around that. So for what Ram brought up, I'm glad you did, Ram. The sometimes you can't really have a complete, a meaningful success or fail. We have some operations that are made up of more than one action, right? Maybe with the same database or the same backend, maybe with multiple. We call those transactions because they're made up of more than one action, right? They're made up of an action in more than one place, right? And if I want to complete a transaction, what could happen is I could have success on the first one and failure on the second one. Well, now what do I tell my client? Was it successful changing the address? I changed it in dependency number 1, right? Did it get changed in dependency number 2? I don't know, probably not. So it's kind of like a unsure and uncertain result, right? So we have to have some way to give a real answer to our client that is telling the truth if we're going to build a reliable service. And that's what Rem's alluding to with this chat rollback, right? We have to have some way to make sure that both of these are successful or both of these are failures. We're either going to change the address in both places or we're going to fail to change the address in both places, and we're not going to have it updated in only one and not the other one. So I do have a little bit more on that. Transactions, it's a formalism in computer science. It has this nice acronym ACID, right? So what we were just looking at was atomicity, an atomic unit of work. I want to do two things as one, as an atom. I'm going to demarcate. I'm going to do action number 1, action number 2, and if they both don't succeed, I'm going to roll back. If they do succeed, I'm going to commit. So the transaction is a unit that either succeeds or fails as one thing. That's atomic transactions. And there's more to ACID transactions. We can do all of these in Mule. We can do consistency and isolation, not so much durability. That's more a job of the backend system. So for a transaction to succeed, it not only has to be atomic, it also has to be valid. It has to make sensible changes in both of our systems. That's what consistency is concerned with, that when I change the address in dependency number 1, I don't put a Canadian zip code on an American address, right? And that's not something that is clear, apparent in the text, like in the bytes. You can't just look at the JSON and know the answer. Sometimes you have to ask the backend system. And even if you think you could figure out if postal addresses in America had Canadian zip codes, there are some things you certainly can't. You need the backend system to tell you if it's consistent. Like maybe 2 different customers can't have the same address for some reason, right? I don't know, or maybe they can, but that rule, that business rule, exists inside your dependency, not inside your integration service, right? So you need to ask the dependency, hey, is this transaction okay? Yes or no? And then the dependency is going to tell you, yes, it's okay, or no, it's not okay, right? So we can do ACID transactions in Mule. I guess, I don't know, we might have time today to even do one. Pull up Anypoint Studio, do a little transaction exercise. I kind of like what you're going with, Mark. I think I will go that direction. Mark put something about an error strategy in the application code for async reprocessing with MQs. Maybe we'll go that way, right? Some of your dependencies can be queues, right? So there's another pattern when you have, the bigger your transaction gets. Let's show this. Maybe there's 3 dependencies, and maybe there's many actions that need to be taken, and maybe some of them have to depend on, some kind of human that has to approve or something. So slow actions. Some transactions they're not very well. The requirements make regular ACID transactions extremely expensive, and I'll illustrate that. Imagine like both of these are going to be successful, right? But in order for this whole transaction to succeed, we have to acquire a lock. Like we have to reserve resources for the transaction in dependency number 1, right? And so if the transaction starts right now at 11:28 a.m. Central on Friday, October 25th, and then the steps 1 and 2 finish in 2 seconds, right? Or 30 milliseconds or something fast, right? And then it goes to step 3, and we're like waiting for that, right? We're going to wait for the person to do whatever they got to do. Maybe they need to go look at a satellite photo of the place to make sure there's room for a swimming pool. Like some transactions involve a human action that could take a really long time. Sometimes it's even a computer action, but it could take a really long time. It becomes very expensive to lock up all of our data in dependency number 1 and dependency number 2 for hours and hours and hours while somebody's doing their job, right? So we have come up with design patterns for designing reliable integration work that doesn't depend on a single atomic transaction. Instead, we can divide that transaction up into a saga, which is just like multiple steps in a story. Some of you guys might be into reading sagas or watching sagas that are movies, right? The Star Wars saga or the Twilight saga or Lord of the Rings saga. Anybody got a favorite saga? You can put it in the chat, right? A saga is multiple stories that fit together into one big long story. Now in transactions, in reliability engineering, sagas are not linear. They don't just have one series of steps. They're more like workflows, right? It's a sequence of transactions that have like, okay, if step 1 works, then we start step 2, and if step 2 fails, we have to do step 3, and if step 2 succeeds, we have to do step 4. So you end up with some conditional logic sometimes in your sagas, right? So you can orchestrate those, or I'll do choreography maybe another time. And we do sagas in Mule. There's a reliability pattern. This is kind of like old school Mule language here. We call it the Mule reliability pattern. We create a series of transactions, a series of steps where together as a whole they accomplish the goal of the action, right? So somebody puts an API call to change their address, they get a 200 okay, even though all these other things haven't finished yet, right? We want to give them 200 okay. We want to say success. I've got it from here. Trust me. What your reliable acquisition transaction does is it takes responsibility for some work, and that's really a way to achieve pretty high reliability. Don't worry about it. My system's got it from here. I'm going to make sure your work is taken care of. 200 okay. Here you go. And sometimes it's not 200 okay. Sometimes a reliable acquisition flow is like, I found your file that you uploaded to my FTP server. I've gone and started my processes with it, and now I can move it to an archive folder, right? So that still indicates success to whoever put the file there, right? So reliable acquisition is meant as a way to acquire some work that the integration needs to go do and clearly communicate to the consumer that provided the work, I'm taking care of it. 200, well, it might be 202 accepted if it was a HTTP request. It might be deleting a file of an FTP server. It might be, it might be sending a confirmation email. If you received an email from a customer with an attachment or something, you want to send them a confirmation email. Yep, we've received your order and we're going to go take care of the rest, right? So there's some kind of synchronous communication before the actual promise has been kept, right? Reliable acquisition makes a promise, and then it's up to us to go keep the promise. We got to have some way we're going to keep the promise, right? Queues are a way to do that. So we can use message queues, like Mark said. Mark said something about the Marvel universe too. I don't know if I can make this a Marvel example. I don't watch enough of that. So here's why we have JMS in the Mule picture a lot. JMS is not the only way to do it, but it is a good way to do transactional queues. And what does that mean? Well, if I'm putting something in a queue and I need to roll back my transaction, JMS supports that pattern. I can make a connection to a JMS compliant system like ActiveMQ or something and begin a transaction. And now anything I do next isn't final. I can publish a message and the broker, which is across the network, it's another computer. I've uploaded my work over the network to the broker. The broker made sure that everything is cool about that. The queue exists. I'm authorized to write to it. It checks all the boxes. Yes, that publish would normally be fine, but it's not final yet. And then after that, I send another message and I say, commit the publish, right? And then it'll actually make the message available to the next process, right? Or I could say, never mind, I had a problem, roll back the message, and it'll never be released to the next client on JMS. And that becomes really handy for building chains of building sagas where I have transactions that chain together. So reliable acquisition enqueues the work into a JMS queue. And then, well, let's do a little example with it. This will be fun. Let's do a little saga example. You guys, I have not done this yet in any point code builder, and I could. But I'm going to use Studio or Code Builder. What do you think? You have an idea in chat. Anybody using Code Builder yet? I could be brave and do it in Code Builder. The study group, right? Let me close folder. I like any point to file new. Oh, I know what I'll do like this. So how do you make like a new project? See how new I am at it? There we go. We'll show it. I'm going to implement an API, or I'll just develop an integration. Here we go. This is going to be example study group, example reliability study group. Can I type in here? Come on. I have to actually browse. Okay, fine. There we go. And that looks good. Create the project. Trust the authors. All right. So what I want to do is, well, let's imagine we're creating a process that has to go scoop up a bunch of data out of a database and treat it as a single unit of work. That was kind of slow. Did you see how long that took? I was like, it's cool. But this is the new version. Code Builder came out 2 weeks ago, the latest release. So if I get, well, I'm not going to give myself that out yet. We're going to add a flow. See how that goes. That's fine. Oh, can I type the name here? Or do I have to? Hey, there we go. Little pencil. Hey, good. This is going to be transaction flow. So we're going to make a single transaction first. There we go. And what just happened? Now this is not visible anymore. Save, close, and open that up again. Where'd the graphical view go? Do I hit that? There we go. Good. All right. I want to add a database connector. So we'll do like a database select. There we go. And this one's going to be, yeah, we'll edit that. Well, this is going to be like order batch. We're going to make a process, and we're going to do reliable acquisition first, right? So we're going to take, oh no, we're not going to do reliable. I don't want to start with a saga yet. I want to start with like, let me get, this process is going to be, I'm going to do a retail. So this is going to have to go get the pending orders, right? So from orders where status equal pending. There we go. So we've got like a batch of orders here. You can't really see it there. I wonder if I can make it like Code Builder. All right. I'm just doing pseudocode here. I used to do this with Studio, so bear with me. All right. Now what we're going to do is I'm going to add a listener. Right. Oops, back. We want connectors, HTTP listener. So this process is going to get kicked off by like post. It's going to be like order batch, right? So the idea is we want all the pending orders to get processed, right? To get, and I'll take these orders, and probably what we'll do is we're just going to ship them, right? So I'll make a for each. So what's going to come out of a database select is a bunch of rows, right? So we'll do like a, wait, where's it? Scopes? Here we go. For each. So we're getting a nice code builder experience here. It's study group, right? So for each of the orders, we want to let's do a lookup. So I'm going to go look up the warehouse that we're going to ship it to. So maybe we have different warehouses all over the world. I'm adapting an example that I did in my architecture class. This will be fun. So look up warehouse, right? And then I wonder why that didn't change. There we go. There we go. Cool. And then after we look up the warehouse, maybe we're going to make another HTTP call with the warehouse information to go send it, right? We'll look up the warehouse and then let's go send it. So you can do a lot with pseudocode here. I'll do it in XML. This is going to be send shipments. So it's for a particular warehouse too, right? So some of them are going to go to warehouse 1, some of them are going to go to warehouse 2, right? Send shipment to warehouse. 1 shipment warehouse. There we go. How does that look? I mean, this is fun. All right, cool. So we're going to loop over all these orders and send a bunch of shipments to the warehouse. Now the trouble with this flow is if any one of these API calls fails, the process dies in the middle, right? So let's say we have like 1,000 orders in our database. We go pull them out of the database, and then we start looping through them, and order number 1 to warehouse in Kentucky, or order number 2 to Florida, order number 3 to Argentina, order number 4 back to Kentucky. We break in order number 5, and we've already shipped 4 of our orders, right? They're gone. We already made all the API calls, right? So that gives us no way to like stop in the middle. Like there's no way to do a rollback, right? So what we could do is we can put this send shipment part in a dispatcher flow. The Saga pattern is one way to take a non-transactional process like a HTTP call and to put it behind a queue, right? So I'll take this request and I'll delete that, right? And I'll make another flow. We're going to add a flow, and this flow is going to, I guess I'll do like this. Send shipment. This is the send shipment flow. And it's going to start with a queue. This is the Saga pattern, right? So we'll put a, we could use any kind of queue. I don't know. Do I have to do this? There we go. We could do, I'll use JMS since I had it on my slide, but you could use a lot of kinds of queues. We'll use JMS queue. And we're going to on new message, right? So now this flow's job is to listen to the shipping queue, right? I'll say shipments, or a shipments queue. There we go. And in this flow, we're just going to go ahead and do that original API call. All right, we're going to go make an API call, and we're going to send shipment to per warehouse, whatever the, based on the contents of the message, right? So now we've got a queue that does that, right? And we can go back to our transaction flow, and instead of sending an API call to the warehouse, we can publish JMS message like that to the shipments queue. Where did it go? JMS I'll put shipments like that. Yep. Wait. Yeah, there you go. Good. And the doc name is going to be shipments. now I want to switch to my other flow, transaction flow. Now, when we're looping over all these rows, we're going to look up the warehouse and we're going to publish to a queue instead of immediately calling an API call. How does that help anybody? Because even still, we could break in the middle. How does putting a queue here make any difference? Any ideas? How did we get down this whole road with queues and databases? What's the name of my flow that I'm in? It helps because now we can use a transaction. We aren't using one yet. We can use one though. I can put all these publishes inside one transaction and then roll back or commit based on if they all succeed, right? Yeah. So let's do that, right? So what I can do is I wonder if I can refactor yet. This used to be more of a Anypoint Studio. I can right click, wrap in a try. Here I can't do that. Here I have to actually make a try. I have to go ask their team for that. Let's see. Is it scopes? I missed scopes. Scopes, try. That's what I get for. Okay, good. There's my try. And now I can put the for each. Oh, I can't. Oh, well. I guess I'm going to have to move the XML. There. I can put the for each inside the try. So now I have a try scope where I have this option to set a transaction type and a transactional action, right? So if my try scope defines a transaction, like always begin, now when the Mule event enters the try scope, it's going to, this is a lot. Let me save that and close it. When it enters the try scope, it's going to create a transaction on the try scope. No, I see the comment. It didn't let me drag and drop. See, we're learning Anypoint Code Builder. I'm learning Anypoint Code Builder today. So before it ever gets to the for each loop, it's going to now create a transaction along the way. And then by the time it gets to the publish, a transaction already exists, right? So when it connects to the JMS broker, it'll begin transaction and then publish the message. So as we're looping over however many thousand orders, 1, 2, 3, 4, 5, 6, 7, boom, we run into an error looking up a warehouse or something, it can roll back the last shipments that we already published. And none of them are going to go to our API call in the other flow, in the shipment flow, right? Because this queue doesn't have any messages until the transaction is committed. Right. So now we've got a way to hold on to all of these publishes until we know that all the lookups worked. Right. 1, 2, 3, 4, 5, all the way up to 1,000 or whatever. And then send all of them at once. Boom. Published to the shipments queue. Right. So we've done something to avoid partial failure. Right. Now, what the reliability pattern does is, well, let's imagine that that's not all we need to do. Okay. Let's also imagine that not only are we trying to ship all these things, maybe at the end we want to go update the database and, mark all these orders as being shipped, right? So maybe we got a bulk update statement down here at the bottom, and this thing, its job is to mark the orders that they have been shipped, right? So let me mark that here. Can I do that in here? Here, I'll use the actual graphical. That's better. So set status equals shipped. There we go. Nice. Right. So now we've got a step in here that after all these get shipped, we want to go back to the database and mark them as shipped, and that can fail too, right? So if you need to do two different things in like JMS and database, or two different databases, or two different JMS brokers, you can no longer use regular transactions. There's a special kind you have to use called XA. And it's this open standard that it's a lot more heavyweight, but it's possible to use it. So we can switch it to an XA transaction. We have to do a little bit of configuration that in the connectors. So you have to make sure that the JMS connection is XA compliant, and you have to make sure that the database connection is XA compliant. But then you can put this bulk update statement inside the try. So like this, right? And it will then be enrolled in the same transaction like that, instead of being a separate item. See, so now the update happens inside the transaction, right? And when it loops, it'll it'll do all of that and roll back all of it as one unit of work. Okay. And as long as our data is not being changed in the process, everything's fine here. Now, there's still more reason that this might be unreliable, right? This is my reliability study group. So now, when I select the orders out of the database, I'm going to get however many back, and the database can be changed while my process is running, right? So here I am looping through 1,000 orders, making API calls, publishing to JMS, all of that. In the meantime, somebody else can come along and change my data in the database while my process is running, right? So that's isolation. ACID transactions have an isolation concern. If I don't want my data to be changed while I'm working on it, somehow I have to protect that. I have to acquire some kind of lock on the rows inside the database, right? And ACID transactions can do that too, right? In order for these rows to be locked while I'm working on them, though, the select has to also be done inside the transaction too. So I'm gonna have to move this select statement also inside the try like that. So now my whole thing, it's getting kind of big for my screen. I don't know if I can. Yeah, you can kind of see it. There's a select, there's a for each, there's a bunch of API calls and publishes, and then there's a bulk update. And it's all in the scope of a single XA transaction with try, which is very safe, but it's not going to be very performant because transactions cost you a lot of performance. Right? So now I've got the whole thing safe. And when my select statement runs, the database it has a setting called an isolation level. I can ask it to hold on to those rows and not let other people change them. Right now, here's where the next risk is. Even though my process is now very, very reliable, my process is also locking the database up for a long period of time, however long my process runs. What if this was 10,000 or 100,000 rows? And now I'm going to lock the database rows up for 2 hours while my ETL runs. I don't know if that's very nice of me, right? So it's disruptive to hold the transaction open. So this is a case where we might want to use a Saga pattern because we might not want to hold locks on all these rows for so much time, right? So one thing what we could do is we could take this for each out and go put it in a different flow. I don't think I can drag and drop it, so I'm gonna have to do that. Let's try that. So what I'll do is instead of let me just use the XML. Where'd the XML go? There we go. Instead of having, hey, why did I drag it over here? Come on. Yeah, I'm back to that. Yeah, that's where I wanted to be. So I'm going to take this for each out and make another flow. This will be name equals ship ship all orders. This will be a flow for shipping all the orders. There we go. I like how that little diagram looks broken. I was distracted by that. That was cool. Okay. So now I have a ship all orders flow, and this does the loop, the for each loop. And I think I'm also going to put the bulk date in there. I want the the rows to get marked status equal shipped too. So now all orders is going to loop over my records, set the status equal shipped. And now in order for that to get reached, I'm breaking my process up into a Saga, right? So I'm going to select the orders, right? Where whatever the status is ready. Did I do ready or pending? Where the status is pending, right? And then maybe I can like make that easier to read. I want to see the status now, right? So I'm going to do that like this. I can see it there where status equals pending. Good. And then what I could do is just make a stage in my process. I could make a queue that's just for the whole batch, right? So I'll do that. I'm going to add here a JMS. Hey, oh, wait a minute. I need that closed. There we go. JMS publish. And now the publish is going to go put this into a pending queue instead of a shipment queue, right? So this is just this is a pending batch queue. I'll make it called pending batch. That's really easy to understand. So pending dash batch. There we go. save. So we're going to go put it in a pending batch queue and then immediately mark the database as updated. Why? Because I'm trying to shorten that lock. I want to lock the rows just long enough to go put them somewhere. It's reliable acquisition, right? I'm going to go get them, put them somewhere safe, and then mark them as updated quickly and be done, right? So here we go. I'll put another database statement here, right? We'll go to a database, update, and this is going to set the status to shipping started or something, right? Where did I go? So this will be like status equals started, something like that, right? That way, whoever's looking at the database can tell that I'm working on these rows, and they can look at the value of the status column instead of having a lock, instead of the database locking the rows, right? So I've done a single publish and immediately updated the database in the scope of my transaction, which shortens it. It makes it very quick. And now I'm not holding the locks open on the database anymore. Then if I go to my ship all orders flow, I have a new issue. Now I don't have a transaction anymore. So I need to make a transaction, right? So ship all orders has to be consuming that queue. So let's add that. We're going to add the JMS on the message. And this is going to start with our, what did I call it? Pending batch. So whenever the batch shows up in pending batch, I can actually put that here too. Save it. There we go. Save. Now that loop gets started, and we're back to our original issue though, where we need a transaction, right? Because we can break in the middle. So let's go ahead and add our transaction in here. I'll probably do it with text, but it'll show in the graphic when I do it. So we'll put a try like that, and then at the end, I think this bulk update doesn't go inside the for each, it goes after, and then we'll put the end. Let's try. There we go. All right, so now I've got a try that I can use for my transaction again, right? So I can make an XA transaction. I can even put that on here, right? XA transaction on my try like that. And now my for each is in the scope of a transaction, and so is my bulk update, right? And we've got a two-stage process, right? We've kind of built the same thing as this picture, right? Except instead of a phone, we're picking up from a database table, right? Go get all the data, stick the batch in a queue, done, right? Maybe in our case, we did the yellow line. That's when I marked the database as a new status, right? So here's my transaction flow. I go get my data. That's the beginning. That's the data I need to start with. Then I put it somewhere safe in a queue, and then I send a success response. I've got it from here. Trust me, I'm going to take care of this work. This is the reliable acquisition pattern, right? That's this first part, right? It's in a queue now. And then the second part, we're going to pick up from the queue, do all of our business logic, loop over things, and put stuff in another queue that lets us publish our messages and send our API calls to ship our messages, right? So that's this process. The second one is the ship all orders, right? We're going to pick up from one queue, and we're going to try. Now, I have a bug here, right? We're going to try, and we're going to loop over and ship all of our orders, and we're going to bulk update at the end. This works perfectly if the process succeeds. We do have an issue if the process fails. And if you put it in the chat, I'll give you credit. If the process fails, it rolls back my transaction. Great. But then what happens to all that data that we started with? Did we reliably do our job? No, because it's gone. Because we rolled back our transaction and quit. So when you're using a queue, you can use a transaction for the step where you consume the message at the beginning of the processing flow, right? And that means if an error happens, the message will not be deleted from the queue. The message will still be there and can be reprocessed, right? So in order to do that, we got to get rid of this try, right? Because try scope won't get it anymore. I'm going to get rid of the try like that. There we go. Now we're going to use the on new message event source, and we can start a transaction directly on the event source. Let's see how that looks in Code Builder. Is it under advanced? There it is. Yep. We can set the transactional action to always begin and the transaction type to XA directly on the listener. And what that does for us is now when any error happens in the flow, the transaction is going to be rolled back, including the message reception, including when we pulled the message from the queue. It will not be removed from the queue. It'll still be there on the queue. And that's where we don't lose it, right? For sure, I've taken responsibility for it, and I will not lose your data. It is in that inbound queue. So I can keep going down this reliability pattern road with redelivery policies if you guys want, or I may have already done plenty. Any comments or observations, questions, some other direction you want to go with it? I'm kind of watching my time, trying to leave time for you guys to participate. What do you think? Let's see. All right. Well, okay. I think that's probably a good Friday study group then. I really appreciate any advice. So the Integration Quest study group is we've been running it for what has it been like? I don't know, maybe almost a year, maybe a year already. We started doing our study group last with different topics, and we're experimenting. Right, we do some beginner stuff, we do some advanced stuff. My idea was today's would be more advanced. Sometimes we do automation. Sometimes we have guest people. So the people who come or who this is for, it's for you guys. So if you have any other we're trying to decide what to do with it. What other topics would be good? We're going to put these things on YouTube. If you want more certification stuff or whatever. So I suppose you can join us on our Slack, and we have a community Slack, and you can also, I think this platform that I'm using for this meeting here also has a chat feature. I have to figure out how to use it, but if you can leave comments for me there, that would be good too. And we'd be interested in your recommendations for future topics for the study groups, or if you wanted to volunteer to lead one, I appreciate that too. So thanks for coming.